minor premise and ones that have a conclusion. They're just 3 lines long. It's called a syllogism. And you have a major premise, if blah, 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 blah. If A, then B. The next statement is going to say A. And then that means that you're going to conclude necessarily B. Not necessarily you will conclude B, not that B exists necessarily. But if the physical universe began to exist, then it has a cause. And the physical universe began to exist, we'll say therefore, this is a fancy schmancy, one of them is fancy schmancy signals for therefore. Therefore, the universe has a cause. All right, maybe we got too fast. Let's go back to your questions. But interject where you want. But basically, your questions are all applicable. Wait, hang on a second. You didn't establish B for me. I want to talk about B. Yes, sir.
Well, my question is, what do you do when someone disagrees that the law of causality is valid? And I know that you talked about, you can't just have an infinite progression of nothing dots that don't change.
Yes.
There's a lot of people who will say that quantum physics tells us that things can pop into existence randomly, that they don't necessarily need a cause, and we can't really explain it fully. So they might accept some level of
magic.
Yes.
Sure, let's call it that.
Okay, now when people, the people who tend to say that are not quantum physicists. The people who tend to say that are popularizers or people that want to make arguments. You go back to the quantum physicist and you say, when you say something occurs indeterminately, and that's really the word that they use, indeterminately, out of quantum mechanics, what do you mean by that? This is where you get into a number of schools of thought in quantum mechanics. And we're going to get off quantum mechanics here fairly quickly. I apologize for those that are not interested. But you got schools that are in them. There's something like 11 or 14, or I don't know how you want to count them. I don't know what they all are. Different interpretations of the laws of quantum mechanics. So here's this group of laws of quantum mechanics. Everybody's like, yep, those are the ones we're talking about. Now, what do they mean? When something occurs in quantum mechanics, the one you probably heard at university, if you got into this, was the thing that has to do with Schrodinger's cat. Right? Here's a box, and inside is a cat, and there's a poison gas and a little mechanism that releases the poison gas if a particular particle decays. So this particle decays, it's the box will sense it, it'll release the poison gas, and this poor cat gets killed. I don't know why this is morbid experiment is what he came up with, but he did. In the other case, over the time that you're working on, the particle does not decay, so we're talking about radioactive decay. Does not decay, doesn't start the mechanism working, cat lives. So Schrodinger, by the way, brought this up to point out, it was trying to say how ridiculous this view was. But it got adopted as an actual view. So his point here is, until you open the box, because we don't know, let me back up. The viewpoint at the time, there was a philosophical viewpoint on which a lot of this was based. The viewpoint was called positivism. If I can't observe something, then it's not only even real, it's meaningless to talk about. That viewpoint, by the way, the philosophical viewpoint that underscores what I'm about to tell you is dead. DOA. Nobody believes in it anymore. The philosophers looked at it and was like, that is self-contradictory and it's not going to work. And so it has been abandoned. But it still lives in the interpretations of quantum mechanics today. It's going to take another 50 years, 100 years for it to get kicked out of the system, but it's still in the system because the philosophers that started the thinking and the physicists that adopted it, the children and the grandchildren, so to speak, of the physicists, have remembered what Grandpa told them, and they didn't go back and understand where this came from. Ernst Mach was where Einstein got positivism from, and that's where special relativity came from. As he worked on general relativity, he realized that some of the assumptions he had in special relativity, philosophically speaking, were false. And general relativity was some of the fix in some ways to that. But Mach and other positivists are no longer regarded as that being even coherent anymore. So people don't believe that. People tend not to believe that anymore because it is self-destructive, self-refuting in some way.
Very popular science fiction.
It is, but again, that is the result of influence, not the result of argument. And so the concept here of here's the cat, and until we open the box, the cat exists in two states, dead and alive, and both of them are equally real until you do the act of physically observing the cat. in which case the two wave functions, so the two descriptions of reality, in quantum mechanics, reality is described by a wave function that evolves over time, that the two waves, this wave means the cat's alive, this wave means the cat's dead, they're both there, and then when you open the box, they interfere with each other and they collapse, and one of them turns out to be the way that it is past that point. That's what called the Copenhagen interpretation of quantum mechanics. There's this wave function collapse. A lot of the people who are trying to build quantum computers today are talking in these terms. And that's the reason that, in my opinion, that they're having an inordinate amount of trouble getting them to work, because it doesn't work on that principle. I think we may have something like quantum computers later, but it's not because there's another understanding of the physical universe. So there are some interpretations that are like this weird, the waveforms collapse version of it. There's a very popular version today, and the origin of the multiverse, one of the origins of the multiverse is that there are an infinite number of universes out there. And that each of these quantum events, the one that can take you to the dead cat and the one that can take you to the live cat, what actually happens is, at that point, when you open the box, the universe splits. And it's actually split an infinite amount of times before, a finite number of times before then. But it splits, and there are now two universes. One that contains the dead cat and one that contains a live cat. Each one of them contains a copy of you and everything else. And those universes then split at the next, and so you end up with this infinitely splitting infinite number of infinite universes. And if that doesn't seem like a little bit of an overblown explanation to you, you're probably not thinking very, very cogently. So, but that's what some people want to say. That's a multiverse, there's an infinite universe theorem of
Your
quantum
point,
mechanics.
though, is back to causality. Really, that indeterminacy is based on not being able to observe what the cause is.
Right, and people
It truly doesn't mean that there is no cause.
And that, to me, is the head scratching. Like, how are these smart guys not seeing that very simple statement?
Right.
So that was my point: is that unknown, as in I can't observe it, does not mean it does not exist. Right. This is honestly to get past not to be able to, in my mind, not to be able to get past the point that we all got to as infants of object permanence. You know, there's a point at a baby, put a toy in front of them, and they look at it, and you put the thing in front of them, and they're like, oh, that ceased to exist. That's not there anymore. And then you move it out, and they're like, oh my goodness, new toy.
So, just to regurgitate what you just said, if I'm understanding it correctly, you're saying that in actuality, the laws of quantum mechanics don't tell us that things pop in and out of existence.
Not at all.
They say that if you just measure something, it can exist in two states. Something that does exist can move in two directions until you measure it, at which point only one is valid.
Yeah, the question is reality comprised of an infinite number of infinitely repeating waveforms? Or is it simpler than that, and it's a waveform, and we're trying to figure out how to describe its previous states? So to give you another, in my opinion, a non-silly version of that, the de Broglie-Bohm interpretation of quantum mechanics as a representative of one of the deterministic interpretations of quantum mechanics is to say something like this. You guys remember the two slit experiment? Like, this is where this kind of stuff comes from. The two slit experiment, and so here's these electrons, and they're moving through these slits, and they make this pattern on the other side. And why is it making a pattern? One interpretation is the electron's going through both slits at the same time, and it's interfering with itself. Okay, that's the crazy version, in my opinion. The sane version is this is all happening in some wave-like medium, and here's this particle, and it's moving, and in the same way that, like, you know, you see like a boat moving and there's ripples, those ripples have effect on the boat as well. And what happens is, as it moves and goes through one of these holes, the ripples have gone through those holes too, and the ripples interfere with themselves on the other side, and they pull the particle with them, probabilistically, like you would expect, and it makes it impact into these particular zones in the same way that would work with boats or balls in the water or whatever else. That's called the pilot wave theory, or the Broglie-Bohm version. I'll post something on it so you can have a look at it for those that are interested. I assume most are not, but if you are interested in it, you can look up pilot wave, put that in the YouTube, put up de Broglie. I'll spell that for you. I'll send it out after class. But in any case, this is a deterministic version that says not only do we can predict where these particles will go because we know how these waves behave. And the particle and wave working together, like boats and waves working together, like a surfer moving along the wave, right? The wave causes the surfer to go in a particular direction. The surfer is like a particle, the wave is like a wave in the medium, in the water, that kind of thing. And the surfer can try as hard as he wants, but there's certain states that he's not going to be able to get into because the wave's going to push him somewhere else. That's the Broly bone. That's a weird version of the Broly bone. It's the surfer version of it. So in any case, there are indeterministic models, there are deterministic models. But none of the indeterministic models are acausal models. What they are is unknown. Where does this come from? Why does this happen? It is no argument at all for there was no cause to it. We can't tell, so we're not going to ask the question. That's basically what it means. All right, so quickly back on the topic. So now the physical universe began to exist. Where are we getting that? Well, let's take we will talk about it here as much as we want to, but the reason I'm going to point to the opposite side is, in a good debate, you tend to if you're a really good debater, and by the way, he is, and you'll watch him do this on occasion. In fact, hopefully we'll have some occasion to see him do this. Take something that your opponent has already said that they believe, and work that into the argument. Because then he can't turn around and say, well, I don't believe premise B. And you're like, no, you already said you believe premise B. Right? So Stephen Hawking, not a small name in the physics and cosmology world, not a dumb guy, not a Christian, he's an atheist, famously so, and a person who believes that the universe, that there's not a God standing on the other side of the line, right? He's very clear about that. I should do it. Peter, can you possibly look up on StephenHawking.com or whatever it is, that statement? Peter will bring it up for us and hopefully text it to us or whatever else. It's in his first or second paragraph, but on the front page of Stephen Hawking's website, it's like StephenHawking.com or org or whatever, he makes a statement in there, and I apologize, I should have had this for you before class, but I'll show it to you. He says that all of this evidence of modern science is that the universe began to exist 13.77 billion years ago in the past. All of the evidence of modern science. Now that's I don't know if I would even make that statement, but Stephen Hawking is not on the side of this argument. Affirms premise B on the front page of his website and says all of the evidence that we have is that this is the case. Now, I'm not saying Stephen Hawking says it, therefore case closed. What I'm saying is an opponent to this argument already agrees that premise B is true, and somebody who's authoritative in the field. Now, we can go through all the reasons for believing that, but the reasons for believing that are, we perceive expansion. I forget who was saying one of the most well-established facts of modern science is that the universe was smaller in the past than it is today. You've heard the cosmic microwave background radiation. All that is an artifact of the time when the universe was smaller and hotter. That's our understanding at this point. We see the further galaxies appear to be away to us, the more redshifted they are. And redshift, for those who have worked in the ambulance business, I know we've got a few in the back that do, you got to remember the Doppler effects. There's a siren, high-pitched and then low-pitched, and the faster it's going away from you, the lower the pitch. So that's Doppler effect. When we look through our telescopes, things that are further away are lower shifted. And what our implication is, they're moving away from us faster. So the things that are close to us are moving away from us. The things that are medium away from us are moving away from us faster. And the things that are really far away from us are moving away even faster. And what that the very clear implication of that is, all of this is expanding out really very quickly.
Maybe I'm just a simpleton, but I totally believe that God created everything, right?
Okay.
I don't need to be convinced on that. I know we're challenging assumptions here, so I'm cool with it. But like, in its simplest form, like, if I want to build a car out of Legos, right? I gotta have Legos.
You gotta have Legos.
Like, I can't just build a Lego car out of nothing. Where do the Legos come from?
Well, I mean, that's not being a simpleton. You're asking the question in its most basic form. Where'd the Legos come from? All of this is us wrangling with the most modern scientific evidence to say where'd the Legos come from.
And it seems like all of the exponent, we're trying to back into this with some like totally over-convoluted explanation of it scientifically.
Well, what we're really asking is, when you say Lego, what do you mean? And you're like, well, this thing made of plastic. And what is plastic? Okay, well, plastic is this stuff. Well, what is this stuff? This stuff is this particular chemistry. It's this chemical compound and that chemical compound stuck together. What do you mean by chemical compounds? Well, it's these atoms that are stuck together in molecules. What do you mean by atom? Well, an atom is this kind of stuff. Well, what is this stuff made out of? Well, and at its base level, we think that those things, quarks, are either elementary particles or some sort of some sort of wave disturbance in space and time, and we call it matter and energy. And that's, we'll talk about information theory later, but let's at least say that which we use to represent it is called information. And so what we're really saying is, okay, yeah, but what do you mean by Lego? Because if we get Lego wrong, maybe we're missing something key. So we really want to know what we mean by Lego.
I don't know if I'm losing my mind here. Is there an error with the logic here? Does that last began to exist? Should that be then it has a cause?
No, this is unless I'm mistaken. So here's part of the statement.
You misstated Steve.
I'm sorry. Good grief. Yeah. The physical universe. Sorry.
Okay.
Has a cause.
Has a cause. Thank you. Good grief. Yeah. That's right. Thank you. Then the physical universe has a cause. Right. So we'll say that for the sake of argument now. Well, no, let's not. We got a second. Let's spend just a couple minutes on, does anybody have any question about premise B? So if we say Hawking says premise B is true, that doesn't mean Hawking says therefore it is, but at least the guys on the opposite side of the argument acknowledge that the physical universe began to exist. And the stuff we were talking about up here, of like, well, hang on a second, how do I get around it? The reason that Sean Carroll did this is because we have this argument. This argument very clearly, you're about to see very clearly, implies that God's there. You don't see it yet. All we have, the conclusion is like, well, then the universe had a cause. That doesn't have to be God, right? It could be something else. So Sean Carroll's like, well, here's a possibility for a cause. It's the other universe backing its way into it. And then Craig points out, he's like, no, that's two universes coming out of the same spot. And there are, okay, it could have been an infinite cycle of universes. Okay, well, the physics we understand don't let you crunch back to this bang, or something like that. So, and even on average, remember the on average expanding. So if we're on average expanding, which we have to be, if the starting point was 0, somewhere in the past, then that means no matter how many of those cycles you go through, they can't go back infinitely, they go back to a single point somewhere. And so even if there were 1,000 big bangs before this big bang, there was an original biggest bang, or smallest bang, or whatever you want to call it.
Someone put something up on your screen online, asking about Lawrence Krauss and his definition of nothing.
Yes.
But essentially, I mean, you said it. When he boiled down, he's talking about a quantum vacuum, which is a free energy state.
Yes.
So it's not nothing. It's not no thing, the absence of anything.
Yeah, and Krauss, if I were an atheist on Krauss's position, Krauss would I would be a little upset that he was representing my viewpoint.
Krauss
because
has gotten lambasted.
Yeah, he doesn't do a very good job of it. And you'll hear him say things like, well, nothing can have many forms.
Right.
And you're like, well, then that's not what we're talking about as nothing. We mean not anything. He means a quantum vacuum.
Right.
And all of this, when we say physical universe, to Justin's point, we mean that including the quantum vacuum. So you're right. That's exactly right. So whoever's asking that question, good question, but Krauss's problem is he doesn't say that nothing means not anything. He uses some other definition of nothing, which is not the definition that's being used in the argument, and for that reason, this was what I was saying. If you don't agree on definitions, you're having two different arguments. He's having a different argument. The argument that the theist is making is this argument right here. Now, let's assume now, because of the reasons that we talked about it some, that Hawking says it, and he's got motivation to not say it, that Carroll has tried to get around it and has said, yeah, okay, maybe that one doesn't work. I assume that's what he thinks now. The physical universe has a cause. All right, well, how does that help? Remember, our original question was, and thank you for correcting it, almost got ugly quickly. How do we, what does this do? Does this do us any good? Our question was, does God exist? Not does the universe have a cause? How's that helping me? Well, here's how it helps you. When we say God, what do we mean? When we say God, what do we mean? Now, the traditional theistic concept is some sort of infinite, timeless, spaceless, immaterial, spirit, mind, omnipresent, omnipotent, omniscient, morally excellent, the best that there can be, all loving, all this kind of amazing stuff. And none of it is like Zeus. Dude, really roided up dude with thunderbolts, right? That's not the theistic concept of God from the Judeo-Christian and Islamic backgrounds. This is, and I think I pointed out elsewhere in this class, that Judeo-Christian and Islamic are linear. They're not sitting on either side. Jewish concept of God, the Christian concept of God is the Jewish concept of God, with the exception of the Christian believes that the Messiah is divine. I think, correct me if I'm wrong, there's no belief in a divine Messiah in Orthodox Judaism. Divine where that divinity is of some sort of equal-like status with the one. Right?
With God.
Yes.
Not with equal-like status.
Yes, right. So now there's some room for debate in here, but ultimately, and Islam is the child in some ways of these. I'm sure the Muslim would take exception to that, but the bottom line is the God that Islam talks about is the God of Abraham, Isaac, Jacob, and Joseph, and that Abraham was considered the first Muslim, and that the ultimate mosque in Mecca was built by Abraham. Right. So this is not two different. We can argue that all three concepts of God differ in some ways, but they're all derivative of the same idea, and the original idea is the Jewish concept of God at a minimum. So this God that we're talking about is this timeless, spaceless, immaterial, omnibenevolent, all that kind of stuff. Now, if the physical universe has a cause, remember what the physical universe was: time, space, matter, and energy. That means that the cause cannot be temporal. So it is timeless. It can't be spatial because space didn't exist. Spaceless. Immaterial. Timeless, spaceless, immaterial.
What are you going to do with the energy?
Immaterial is because Einstein tells us they're the same thing.
Okay.
So that's matter and energy.
Act without energy or matter also.
We'll say, why don't we say this? Very powerful, because it brought everything in here into existence from not anything else, no other physical things. So that's interesting.
Without time, without space, without material, but all the energy.
Now watch this. Well, energy and matter are the same thing per general relativity.
Then you need to define powerful.
Powerful, able to actualize everything that you see.
Okay.
Personal. Now wait a second. Hang on there, tough guys. You slipping pulling a fast one on us? Where'd you get personal? Here's where you get personal. Back to who? I don't remember who answered the question or asked the question about the dots. Steve, was that you? Where's our dots?
Yes.
I don't remember where the dots are. You remember the dots, right?
Yes.
Here they are. So now we've said, okay, fine, there's something, fine. You want to do this? Fine. There's something timeless, spaceless, immaterial, powerful, sitting there at this dot. But it's in the same problem, right? What starts it? The point is this: a decision starts it. This thing has to decide to go from, the state is A, this is state A, this is state A, this is state A. We're going to go from state A to here's something that is not A. We'll call it state B. Something's got to decide to go from A to B. Why? Because there's no decision. If there's no free will in there that allows it to change, whatever this is, to change from state A to state B, it will stay in state A the whole time. If there's no cause for that thing to change, and if you're going to say if this thing has existed timelessly, in no time, then how are we getting to a different state? The only answer that remains is there has to be something with free will that can make a decision to move from state A to state B. Go ahead.
How did you know it's immaterial?
Because the physical universe was time, space, matter, and energy, which means that at this, where was my original line? At this point over here, so here's our line, here's the Big Bang, time, space, matter, and energy, all at this point come into existence. On this side of this line, there's no matter and energy. Because matter and energy came into existence at this point. If there's no matter and energy, that's what we mean by material. So anything on this slide has to be immaterial, like math, like numbers, or like God, or like the laws of physics. These are not material constructs. These are immaterial.
What if God isn't some part of material?
Say it again.
We don't know what God is.
Well, we don't have to know what God is yet. What we're talking about is what's the cause to the universe. Forget the question about God for a second. We haven't gotten there quite yet. We have, because remember, in our argument, we haven't said anything about God. We've said the universe began to exist, the universe has a cause. The universe did begin to exist, therefore the universe has a cause. Now, what does that cause have to be? The cause must be timeless, because if it was existent before the universe,
Okay, that makes sense.
you see what I'm saying? Okay. Now, hold on. Brian, and then
So by personal in this context, we're saying having agency, having free will.
yes. Okay.
Just out of curiosity, then.
Or let's say having, free will. I think I don't like the term free will. To me, will and free will are the same thing. If you don't have free will, you don't have will. So we'll just say agency and will. And maybe what you mean by agency is will. So those could be the same thing.
So in this context, personal, if animals have agency, personal could apply to them in this.
And these gentlemen will make an argument for the agency of animals, I think, later, right? Yes, sir.
Why stuff at once? Why isn't there a pantheon of multiple gods interacting, and one of them says, "I want a universe"?
Could be. That doesn't help us out yet. All we know is that at least one. Occam's razor gives us one God.
At least one.
Yeah, at least one, maybe more. Right. So we'll talk about how do you know not more than one in a bit.
I actually got a different thing out of his question was, what if the singularity is God? Therefore, if the singularity is material, then God is material.
You got it. And that's why it can't be.
Right.
Right. You're right. All right. So this right here is going to be kind of step one. All right. So we've got an argument that it's really, if the universe began to exist, then the universe has a cause. Let's assign a level of certainty to this. You know what I mean? Like, to me, this is like 99% certain. I would make that like 99.999% to me. Because remember what our consequence was of not believing something like this, is that universes just pop into existence all the time, inexplicably. Boom, there's another one. Boom, there's another one. Boom, there's another one. If you don't believe in this, science is dead. If you don't believe in the causal principle, you don't get science. You cannot justify science if you don't have this. So you can't think scientifically. As someone pointed out, Steve pointed out maybe, you have difficulty thinking rationally. Well, how are you even going to think if something like that's not true? So I'm calling that 99.99%. The physical universe began to exist. Well, let's say Hawking's right and that all the evidence is that that's the case. If you said of the evidence that we have, something like, he says, maybe he doesn't mean 100%, maybe he means 99%. But we could be wrong about that. We were wrong about a lot of scientific stuff in the past. But let's just say that by the physics argument here, that makes us 75% confident or something like that. And let's say by the metaphysical arguments, stuff that's like Peter brought up and others brought up, the Hilbert's Hotel kind of thing, the physical universe couldn't just keep going back in the past. Let's say that the philosophical arguments give us something like more than 90%. You can see that no matter how you want to combine these numbers, you're going to be pretty darn certain of C. And a lot of times, if you argue with people who haven't interacted with this argument before, they'll be like, yeah, okay, I get it. The physical universe had a cause. And then you say, well, here's the implications of that. And by the way, I've had this experience a few times in my life. Yeah, okay, I'll buy the conclusion. How does that help you? Well, timeless, spaceless, immaterial, powerful, and personal. And you know what that smells an awful lot like? God. Which is why you see the gymnastics that occur afterwards. And what I want to point out to you is, this is one argument we'll talk about. The thing to look at here, the thing to watch here, are the gymnastics. The gymnastics that occur on the other side, and how do I avoid this fairly obvious and convincing conclusion? How do I go about doing that? And the fact that I want to do that only occurs after I learn that the argument to which I agreed initially implies that God, that something like God has to exist based on what we see and based on our best scientific evidence, right? So to look back at this is our best metaphysics tell us this. our best physics tell us this. When you combine our best metaphysics and our best physics, you end up with this. And a lot of people don't like that. But remember how we got there, and remember that a lot of people that don't like that tend to only not like it once they find out where it takes you. Which, by the way, a common experience to all of us, right? You'll see this in religious argumentation too. I've watched these guys do it a couple times. They're like, well, you believe A. You're like, yeah, of course I believe A. And you're like, you believe B. Well, yeah, I would agree with B. Well, A and B add up to C. And like, well, hang on. C's not true. I don't know. That was a deductive argument. You just said you agreed with A and B. How can you not agree with it? But we do this all the time. A lot of us do this. Maybe all of us do this. But here's my point. This is our first step, and we're not going to say, I've got an argument for God, checkmate, game over. Let's not do that. Let's be as broad as we can. Let's walk as far forward as we can based on all the knowledge that we know at this basic level and see where it takes us. And all I'm saying is that this particular kind of thinking takes you to this kind of conclusion. Very solidly. Deductive argument, very plausible premises, highly confident premises, and things that are necessarily the case if the premises are true. So this is, in my opinion, this is one of the kinds of reasons why it's way more rational and scientific to be a theist than it is to be an atheist. This is one example. We'll do a couple more next time, and what we will build over the course of this first part is over this fall is the case that theism is the intellectual's position. The theism is the scientist's position. And that theism is the philosopher's position. And that in order to adopt a position that is not that, you're going to have to go against the best evidence that you have and the best metaphysical principles that you have in order to pull that off. And if you think about that, if that's true, think about what that implies. Think about what that means. And think about what that ought to mean for the way that we do business. And I think that what it ought to do is give you, again, if this is all right, it ought to give you the kind of confidence that I have come to have now. I used to think that there was a lot of, maybe I'm just believing this one. That's not what I think anymore. Now I think is this. If I think at all, if anything that I think is true at all is true, if any of the stuff that I believe basically to be true is true, not only does God exist, it's certain that God exists. As certain as I can be of anything, I'm certain that God exists. And it's a result of walking through these, not just the arguments themselves, because you look at this argument itself and you're like, okay, yeah, fine. How does that make me certain of God? When you think about the implications of it, when you think about how you got to these things, how you got to this thing, and then how you got here, then you're like, no, I do understand. That is, all right, that's solid. I get it. That's where you ought to be. And if you're not there, let's keep talking about it until you either get there or you say, hey, hang on a second. You've written some of these. This is not correct. You've written something wrong here. Yeah. So thank you very much. All right. We are out of time. But we will continue this type of thing next time. Another invite to y'all. And you kind of know the things that we're going to go on to next time. If you want to present and work your way through any of these as well, the floor will be yours at your request anytime you would like to do so. I think it would be a benefit to have more than one guy walking us through this kind of stuff. So feel free to do that, or if you want to dialogue about it, let us do. And that offer goes for anybody that has a particular viewpoint that they want to represent. This is a bully pulpit, and I don't want to use it as a way to, because at the end of the day, we're going to agree right up until some point that we'll say, and hopefully it won't be Easter, actually Easter, because between Passover and you guys not being here and Easter and all. But at some point we're gonna diverge, and at that point we have to be dual, so to speak, in front. But I would like for there to be as much discussion about this as is desired by people who are not confident in some of these things. And let me make one other offer. Let's say, this is the last thing I'll say, but this lasts for the rest of this semester or whatever year. If you say, you might be thinking to yourself, other than I can't write a simple deductive argument correctly with 3 lines long, hang on, I don't want to go up against Scott. He talks too fast. He talks, he's clearly thought about this stuff a lot. I have an opinion that I think he may be wrong about, but I'm not going to put myself on the hook so much as to sit up here and talk straight across from him. Okay, I got it. Give me the premise, and I will argue your premise for you. And then we'll let some of these other guys be the attackers on it, whoever wants to. and I'll defend your position. I will promise you to the utmost of my ability to do so. And you can at least see me attempt to fight for it. If I fail to, you can either chalk it up to my own insufficiency or to the fact that the argument wasn't any good. But if there's something you see that you don't like, tell me and say, I'm not convinced. I want you to fight that position, and then we'll do that. Because then if you ought to be able to do that, or you're not in an honest debate, right? Okay. Thank you all very much for your time. You all have a great week. May God be with you, and we'll see you next week.
Let's go next.
You go Nats. Yeah. Yes, sir.
Universal.
Where is that? Oh, yes. Thank you. Physical universe.
What's the first date? You said you would argue.
Yes, I would take that on.